I'm going to cover SOLR 101 in today's session, and SOLR is one of our core search technologies, and the way we have approached this is we'll start with very basic about SOLR, and then in the subsequent months Chris will cover like more complex and like how to build up web applications and with SOLR in more depth and kind of like real-time example. We felt like the importance of knowing the basics of SOLR is so key to do anything like big, like building applications with our one-cart merchants or anything related to search. So that being said, the topics which I am going to cover today is generally about search, an overview of search, why is it important for an e-commerce site, and SOLR fundamentals. Like I said, the very basic things which anyone should know about SOLR before building like applications. And one of the key data structures with SOLR is inverted index. So the beauty is that you have to know only about inverted index. There are not many complex data structures involved. It's very simple, easy to understand. I'll go in depth, and some of the core components of SOLR, the basic components and what it does. There are only like 3 such components, and I'll go into depth in each one of them, and I'll take some questions at the end. And before I get into the details, I thought I'll share some of the experience which I had in the domain of search, and why am I like passionate about SOLR, and I want to like really learn about it. So in while I was doing my masters in Virginia Tech, my thesis was about search. So it was about the scalability of search engines, and I implemented that using Lucene, which is a Java based library on which SOLR is built. So it's kind of like search is near and dear to me. And another fun fact is, so when I got hired for NextJump, pretty much I think they saw I have done something with search, and they put me in the Boston office because there was a project coming for search using the Google box. So at that time, NextJump, we bought a Google box, enterprise box, and we plugged in into this site to do all the search stuff, which we have moved away from at this point. Also in 2011, we used SOLR for integrating with Mercury, because the data is growing in Mercury, like the scale of the data and the amount of emails which we send. So we felt to scale the search within even Mercury, SOLR is the great technology to use. So that's the reason like I really like the search and kind of like the great things which we can do with it, and want to like cover this basics. Before I go into like any details, I want to like all of us to understand why is search so important as a user. So if you go into any shopping site, imagine you trying to buy something, like every shopping site offers millions of products, and without search, browsing through and finding a product, particularly like the smaller things like a vacuum cleaner or kind of dog food, anything like which is really the smallest of the SKUs, it's going to be really impossible without a great search experience. And even with all our experience, I think the most common way of shopping is search, starts with search. So that's the reason why it's kind of like so important to know about this and build the right technology even to run on our e-commerce sites. And I want to quickly go through the tech stack which we have at NextJump and where SOLR fits in. This is something Albert and Tom covered in their first Friday. So if you see, SOLR fits in under the data layer, and among all the like great technologies which we have and powers our commerce site, it's one of the key kind of technology which is present. Now I'll talk about little bit about, so we have data, all these like products or anything which is related to the e-commerce site. Why can't we do all these things with a database? Just put all the data into the database and use the database search, versus why do you have to go for a new technology? So let's go through an example of, let's say we have kind of a lot of documents, and somebody wants to buy a home and they want to search for like buying a home. That's like one of the example use case. And if we want to query our database and find documents which are matching this, there are a bunch of ways of doing this through database SQL. Like so the first example is like select books where name equal to buying a new home, and there are like a lot of other ways of doing it using the like class and so forth, and each one of these have challenges with the database query, meaning like the first one will look for exact match of the name as buying a new home, and then the further other examples will look for like documents, but it would give you either a very fewer relevant documents or too much of irrelevant documents. You wouldn't get to an like optimal state of like finding the right set of documents which matches your query. So these are like challenges, and also other issues like cost of these operations are much high when you use a database search. So for all these reasons we want to move away from like the database based search to the technology which is meant to do all these type of operations. And here so what is the type of technology which we have to go for is like the NoSQL technology, basically like moving away from the database side of things. And I want to like touch briefly at a high level about what is like the problem which a NoSQL technology addresses. So with the growing volume of like the data across all applications, particularly with the e-commerce sites, the scalability and availability of these modern applications becomes more and more important, and for addressing all those needs we go after like NoSQL technologies. Even within NextJump, if you remember, we use Redis and all these other things for caching and a lot of things. So those are meant for a certain type of job. Now SOLR is one such NoSQL technology which is meant for search domain. So for the like searching and having a good experience for the users, SOLR is a perfect NoSQL technology which is out there, and we decided to use that. Now so I'll start now with the Apache SOLR. At a high level, what does it offer? So SOLR offers a lot of like great features like scalability. As the document or like the data set grows, it can scale to a great extent and support, and it is very optimized for search. So I'll touch later in the presentation what is exactly like search, what are the characteristics of a search, and how SOLR is very much optimized for it. And great thing is it's ready to deploy, meaning all this work of like indexing and how the query happens, the text analysis, everything is available out of the box through SOLR, and all we have to do is just it's ready to deploy and we can start customizing to our needs. So that's the beauty of it. We don't have to know like so much of details, but the basics will just help us get started and achieve what we want. And the results by relevance, like I said, compared to the database search, the SOLR offers very relevant document result sets to be retrieved from your data, and it's meant for like the text centric querying, which is like meaning most of the data which you will deal with will be text in the domain of search, and it can scale with volume. So those are like some of the overall features of like why SOLR is very cool and good technology. And quickly I want to like also share what is the relationship between SOLR and Lucene. So Lucene is like a very barebone Java library which offers all these like classes and things which are necessary to implement the kind of like it's kind of like the API. You can imagine it's like library of like classes which does all the work with related to indexing, querying and everything, optimization and whatnot. And so it's more like an engine of a car, and SOLR is like fully built car. It makes it like ready to like drive or ready to deploy in your enterprise and start using it. And so this I want to share like to give you an idea of what are the sites which are out there using SOLR. So Best Buy, Netflix, even Apple and some of like the finance companies, even I think Bloomberg uses SOLR. They do a lot of research around SOLR and try a lot of things. So a lot of companies are using SOLR because it's really like easy to use, and it can deal with like really high volume of data and scale. Then coming to the SOLR, so where does it actually run? So SOLR is a Java web application, which means it can run in any of the Java servlet engine like Tomcat or Jetty, or in a full-fledged J2EE application server like JBoss, Oracle Application Server or IBM WebSphere, and in next jump we are deploying SOLR on JBoss. So that is something to be aware of. Now let me start getting into the details of like little bit details of like the SOLR and what are the concepts with the data structure and other main components. So like I said, the one and only data structure which is kind of important to know with the SOLR is the inverted index. So what does an inverted index mean, and how does it vary from the forward index? I will cover in the next two slides. So if you see, in search domain we deal with a huge amount of documents, and the way we store the documents in SOLR is using this inverted index data structure, where let us say you have a document with so much of text information. Your word is going to be like the how it is listed here, that is going to be like the primary kind of like the identifier, and the document in which that word occurs is going to be also stored, which is kind of like the secondary information. Now this is the most simplistic view of an inverted index. We can also store information like the position. So basically the term position within each document can also be stored, which can be helpful when we go for like a very sophisticated like how much the relevance calculation and all those things further which we have to do while querying will be more sophisticated and good as we do kind of like those sophisticated stuff with the index. So it is nothing but like having the form of like a word and the list of documents in which it occurs in a sorted order is nothing but like the inverted index data structure. Now how does this compare to a forward index, which is the typical way we store in a database is, we will have all the documents or using any document ID, be it the name or like a unique document identifier, and we will have the list of words being stored as the secondary information. So this is how typically it will be stored in a database, and how it is done differently in the inverted index. And the inverted index plays a key role in how efficiently and quickly our search works, because we are storing that information in that format. Now as I talked about search, it is very focused on like text centric data. It is not just like product information and just the number, like a kind of numeric representation and dates. It has big text information, and that is why I think the text, knowing about the text centric data and how we process that using SOLR is important. So SOLR is optimized to work with the text centric data and also read dominant. So when it comes to search, more than like pushing information into the index, what happens more commonly is getting the data out of the index. So that is why we call it as a read dominant. And then it is document oriented. Like I said, it is all treated as a document which we persist into the index, and there is a support for flexible schema. So all these characteristics makes SOLR like very optimized to handle text centric data. And then I will quickly cover the SOLR feature overviews. It offers a lot of features, and it can be classified under different buckets. So it offers like out of the box lot of great user experience features, like once you get the results, having automatically the pagination, sorting the results in a certain manner, faceting, which is nothing but like grouping the documents under a certain topic or a subtopic. Spell checking, if there is some, if you have typed your search with some errors, it will suggest you, do you mean really this? Hit highlighting, let us say you are searching for a query term and you want that to be highlighted wherever it occurs in the result set. And even like when we have some information related to the geospatial stuff, and if you want to use that feature. So lot of these things are automatically available along with SOLR, which is kind of like easy for us to just plug in and use it. And there are a lot of other features with respect to like data modeling, as well as the latest features which are available through SOLR. Now when it comes to like the three main areas which we have to be familiarized before building like big application is, how do we set this up, SOLR on our like a dev or anywhere, and then what are the two main areas or like the two main steps with SOLR. One is the indexing and the other step is like the querying. And then while we are installing some of the configuration files, there are a lot of like different XML and like text files which you will see while you are installing it, but I have felt it's good to just know these three as a beginner. The SOLR.xml, which will have the list of the codes or collections, which I will touch later what it means. It's basically like where you are storing the data. It's kind of like that basic and high level information. And the second one is the SOLR.config.xml, which lists all the handlers, like what is the type of search handler you are using. Are you using the default handler or some custom written handler? And replication, how does the data replication works? And cache management, are you like caching the results for the query which somebody is executing, and how does that work? So all these like high level stuff related to server are listed in the SOLR.config.xml. And third one is the schema.xml, where you define most of the information related to the document, like the fields which are occurring in a document. Once you design how the your document is going to look. For example, let's say if you take a product with Walmart, you can have like a product ID or a SKU ID, and then the name of the product, and the other attributes or details related to the product, and the type. So there are like primitive types like the string, date, and all these things, as well as you can define your own text types, and which are more like the complex types. Also the schema will have the text analysis, which is one of the most important like component which we had to be aware of while using SOLR, which I will cover in depth. And then, so before I go into covering like the indexing, text analysis, and the querying in depth, I want to kind of like give you a picture of once you say like, okay, I installed SOLR, how does that represent? And I want to give you the picture of like the basic and simplest form is, let's say we have a SOLR and just one instance of SOLR, and how actually it will translate to, let's say for next jump we have a lot of these one cards, and how does that represent? So within one SOLR server instance we can have many cores, and each core can have an index. So for example, let's say we have Best Buy, and at least like at the moment we have implemented for every one cart merchant we have one particular core dedicated, and there are like a lot of ways we are planning to like improve that in the future, but this is kind of like the existing view of it. Each core will have index which contains the products from each of the one cart merchant. Now let's say Walmart is like one of the biggest merchant and have so many SKUs, and at that level or at that stage we can decide to have more we can have more instances and kind of distribute this core across more instances, and that takes us to like the more kind of like the complicated or whatever, like the sophisticated technology concepts like sharding and replication, where if the index is too big and once you query it starts becoming slow, so you are going to split your index and store in multiple instances, and you can also replicate them to run multiple queries against it and kind of pull the data. So it's kind of like we can start from basic to we can like do so many things with this for increasing the efficiency of like our query processing. So this is how we have, and I think right now Chris is working on getting all these products into a single core, and that will translate to I think closely 4 GB of the size of the data which we will have. And once we kind of make them all into one core, it's going to be more easy for us to manage like the amount of code, and as each one cart merchant comes in, it's a matter of like just changing the configuration and dealing with it. So kind of like want to give you the picture of how we are designing and using it. Now getting into the main components of SOLR, I know this picture can be like overwhelming, but the kind of like the funny thing is that's pretty much it, what SOLR is about. And these are the 3 main components which we had to worry about or like learn about as a beginner. And once we know this, then we can like do so many things in each one of these in depth. Because these components represent most of the work. Everything else is more like one time, like a query management or the caching management or like the installation and setup or kind of one time thing. More work goes into each one of these on an iterative basis. So the Steps which we have are indexing, query processing, and to both these steps the common thing is the text analysis pipeline, which is where most of like the data massaging and transformations happen, and I will go really deep into it. So I will start with the text analysis. So I want you to just keep this in mind that we index the data and then we query back the data, and for both text analysis the most common kind of phase. So what does actually text analysis means and why is this so important? So as we have all this huge amount of data set, if we do a good job of transforming and making the data in a way that it is very optimal and get the right data into the index, it becomes more efficient while we are querying back, and there is a good chance of getting the relevant document back. And same with querying, taking if let us say somebody types a very natural language query like, oh I want to buy a new home. If we have a powerful text analysis kind of implementation, it will help in finding again translating this query into a meaningful form to get the matching documents. That is the reason this plays such an important role. And quick example I want to share to get you a connection is, let us say somebody wants to buy a new home and we have a document titled purchasing a new home. So if we have done a good text analysis in indexing all the documents by finding the synonyms of buying to purchasing and whatnot, there is a great chance of finding this relevant document back. And what does that translate to is offering a very good user experience by using the natural language query process. So with text analysis, I want to share what at a high level what does happen and what are the things which one have to be aware of. So there are three important things an analyzer does in the text analysis phase. First is the tokenize. So in simple terms it takes let us say assume a paragraph of text and it tokenizes into simple terms or words. And you can use different types of classes, the basic classes like the white space, just by white space tokenize these terms, or a standard tokenizer which comes inbuilt with SOLR, and that offers a bunch of more features than just white space. So that happens in the tokenize step. Then we parse it. By parse, what it simply translates in maybe computer science terms is the lexical parsing, transforming or massaging the data into turn them all into lowercase and apply the stemming so that you kind of get to the root of the word. The final thing is the token filtering, which is finding the synonyms or removing the stop words like the, a, and all these things. So once your text goes through this pipeline of all these analyzer phases, you get the kind of most meaningful and cleaned up data out of this, which you can put it into your index. And the same thing happens even for querying. Once somebody types a query, it goes through all these steps and your query is the most simplest and the kind of meaningful query terms, which will be very easy for us to match against the documents and get the relevant documents. And then like I said initially, so in the schema.xml, the things which we are going to define are the fields which we are going to have in our document, which goes into the index, as well as the type of analysis which has to be used both while we are indexing as well as querying the document. So it's kind of just want to give you a glimpse of how it looks, and I'll take you through how the text analysis works with an example. So let's say we have a kind of sample application in which we index all the blog or the Twitter kind of microblog text into our index, and let's say somebody is searching for certain thing within that blog. So in this example the query text is San Francisco North Beach coffee, and the search result is going to be whatever is this is the most relevant document, and I will take you through how actually this happened and what are the text analysis which happened in different phases that it was able to get this most relevant search result. So at a high level in the original document or like in the original blog, this is the text which underwent the SOLR text analysis and it got transformed. So this is like the very high level. Now I will show you some of the classes which were applied for this to happen. So if we use the standard tokenizer factory, this is the like the output of the processing, the text analysis pipeline. And let's say we add few other filters like the token filters like the stop filter and the lowercase, you can start seeing how your data started getting clean up, like it will start removing these stop words, everything is starting to get translated into the lowercase. So all these massaging and transformation happens, and your finally like the clean set of words goes into the index. So this is kind of like a summary of how your raw text and terms look, and what are the transformations which happen, and what are the classes which corresponded to those transformations. Those are nothing but like the analyzer like classes which I spoke about. Now so now you are aware of like what happens with the text analysis, which is common to both the indexing as well as the querying phase. We'll take you through the indexing and querying, what happens, which is the actual like, okay, let's start doing the job of like we have the data, how do we put it into the index and query back. So in SOLR indexing, it's kind of very simple. You have let's say the data, and there are many ways to like insert this data into the index. One of the common way, at least this we have done through Mercury, is all our data or like the mailing and every information is in the table. What we do is fetch all those information and convert them into XML documents, and we post through like a HTTP post service, and it goes into all these text analysis which I spoke about using like the standard tokenizer, the filters and the parsers and everything, and then finally gets into the Lucene index. So that's all happens with the kind of indexing step. And things here you have to remember is like how you had to like design how in upfront you had to put, I think this is where the kind of work has to be done, and as we put more thought into it upfront in designing how this document is going to look and what are the really necessary fields which we want to really insert into the index, it's going to be like much more good and like a great solution. So this is the format of let's say a document, and that's the XML representation of this document which we are going to index. And this is how like the full fledged schema will look, where we'll have the list of all the fields which are in our document, and we are going to define the type of the field like the string or date or text field, and the type of analyzers which are going to be applied for each of the fields, both during the indexing as well as the querying. So this completes like how the indexing works. It's kind of you take the document, put through the text analysis and index it. And it's kind of quick view of the field types. So we have the primitive field type like the date, string and boolean, and there are text field types which can be more custom type. You can define what exactly it means, like your complex text field type. And this is kind of like summary of what happens at least in XML. Let's say Walmart or like Best Buy or anybody gives like a CSV or any format of the file. We first take the information and put it into a database, and then we fetch the data from the DB and kind of use whatever like so some can use like the JSON or the XML or any other like serialization format, and put it into the like give it to the HTTP post, goes to the text analysis phase, and it is stored in the index. And some of the highlights of what we do with indexing is we rebuild the index once a day. So it's kind of like for all the products which we have across the different one cart, that's a practice which we use, but because as the data grows, we are going to have like more custom solutions. Why do we have to rebuild for everything? Only for the data which is changing. Let's say Walmart adds only 10,000 products on a weekly basis to the data set. So instead of rebuilding everything, we can just go and build. So those are the solutions which we are like kind of implementing, which are more like neater solutions. And then the final part is the querying. So at a high level, how the querying works is in indexing we use the HTTP post, and for querying we do the HTTP get. And here if you see there are like it's kind of like self explanatory, and I will share this also later on like the presentation. So here we tell the collection against which we have to run this query, and there are like lot of like this query parameters and a lot of other default parameters which we can set. For example, I think it's missing here, but then hit highlight is like if you say HL equal to true, it's going to do the hit highlight, and all these kind of fancy things you can do, mentioning it in the querying phase. And I want to touch back on the inverted index, because I'm going to explain how actually querying is going to work and how it is going to get the most relevant documents out of the index. So if you remember, we had all the name of these books, and somebody is going to search for like buying a home. So the way these are the set of original documents, and then the document text. Now this being the content which we wanted to index, we input in the Lucene inverted index, and this is how it looks. For every term it will tell all the documents in which it is occurring. So this is the representation of the inverted index which we have built for the documents which we had. Now an example of, let's say somebody is looking for a book title with new house, I want to show like how it's actually going to work. The step 1 is it's going to take both the terms new and the house, and it's going to separately look into the Lucene index. So first it will take the home and find out all the documents in which a home is occurring, and then new, and then find out all the documents. So that's the step 1. The step 2, it's going to perform like a set operation to find out what are the documents in which both of these terms are occurring. Now there are many different ways we can do the set operation using and or kind of negation, like just have the first term and not the second term, so many ways. In NextJump we use like the and, so basically look for documents which has both new and the house, which will be the most relevant. If you imagine, like that will be the document which will be the most relevant to what the user searched. But like I said, there are many ways of doing it, and it depends upon like our need and the type of application where we are using. But this pretty much is the most simplest way of like understanding how the querying is working. And once we get the document back, let's say there are many documents in which both the new and the home occurs. Now we can start doing more interesting things, like what is the most relevant document among that. So that is nothing but like relevancy. We start calculating that for each document, and then sort the results from the like highest to the lowest. So for which the most fundamental class which is SOLR uses is the default similarity class, and what this does is it applies like the Boolean model to find out like first the matching documents and leave out all the unmatched documents. Then it applies the vector space model to see the query terms as well as the documents which are returned, their terms, and find out like what are the most relevant documents. So we don't have to go more in depth, but at a high level I thought it will be good to know what are like the kind of steps which are applied to find the most like relevant documents. There are some other like concepts with which comes up with like the querying. Like I mentioned, the out of the box is like the faceted search, which is the high level grouping based on documents, hit highlighting, the spell check, auto suggest, as well as the results grouping. I thought this snapshot will help you like understand, particularly for faceted results. You can the good example is like say you go to a news site and search for some word, let's say flights. Then it is going to show you the news sites, typically the grouping they use is what are the documents or news publications which came in the last 1 hour, 24 hours, 7 days. So those are like the very common method of grouping they use, and that varies from like a different sites. And another thing is the geospatial, which I mentioned, the highlighting. So it's kind of like we can do all these cool neat things through kind of these features. And that's pretty much it. And I want to like let you guys know that Chris will continue this SOLR and focus on building like applications using SOLR. And one more piece of information which I wanted to just share quickly is I heard like a lot of even people in Nextgem haven't set up like the SOLR on their dev, and I have gone through these steps myself and set it up. It's not tough, you can definitely go through it. So I will circulate this presentation afterwards so that you can try this. There's like 10 to 11 steps which you have to do it, and if you guys have any problem installing, you can let Chris or I know, and we can definitely help you get it installed, so that you can start playing around with this and see these XML files and whatnot, and start to kind of get a feel of it, and then you can start changing it. I think that's the way at least I play around with applications. Just set up, get to know these configuration files, start slowly changing like a bit of them, and get a feel for it and further explore it. Yeah, once you install, you'll like see a dashboard, and this is also another like a great forum to play around. You can here itself, what you can do is let's say you have a document, you input the document, and you can see the words which are going to be coming out of the document and how it is going to be indexed. All those things you can play around using this UI tool and get a feel. Even like the querying, like you put a so you can do that indexing, you can query, and you can see what the documents are going to be coming out, the schema, everything you can browse and like get a understanding of it. So I'll leave you with that, and any questions?